All right, we did it. We're on stage. We made it. It's been a long journey. Well, here we go. So thanks for inviting us, and we're really excited to be here. I've been to a few of the conferences over the years, and we've learned a lot about all of you and got a lot of inspiration from your different ideas and applications, and really excited to be able to share what we've put together at Boeing. So my name is Jeremiah Scott. I'm from Boeing. I brought my team member, Brian Beretta, as well. We're really excited to be here and share what we've been working on. Little background about me. I come from a background in commercial photography, and I graduated about 20 years ago. I've been at Boeing for about 17 and started shooting 360 at Boeing about 13 years ago. We started out with some really big ideas, and we put together some really novel concepts. I lead a team called Apex Virtual Tours, Advanced Photographic Engineering Experience, and really amazing, elaborate team of very talented individuals. So, handing it off to Brian.
Good morning. Yeah, I've been an IVRPA member for a number of years, and this is the first time I've been able to actually attend a conference, so it's been really exciting. I agree with, I think it was Sabetta's comments yesterday morning in her presentation, that it's really refreshing to be at a conference where every talk is interesting and relevant. So let's give another round of applause for IVRPA. Like Jeremiah and everybody on our team, actually, I'm a commercially trained photographer. I've been with the company for about 13 years. Whereas Jeremiah comes from the more well-known airplane side of the company, I come from the space division. So I got my start much the same way, doing technical documentation for satellites as they are engineered, manufactured, and tested. And in my previous life, I was a web developer. And so that combination of background has yielded itself really well for the endeavors that we're doing with Apex. And I'm not unique in that. A number of our team has very diverse technical backgrounds, so that's really been the recipe for our success and what we've been doing. All right. So like any good presentation, we like to start off with a few inspirational quotes. So the first one is, every once in a while, a new technology, an old problem, and a big idea turn into an innovation. And we really like this quote a lot because we think it speaks to exactly to what we're doing on Apex. So we're taking a relatively new technology of 360, high-res 360 photography and virtual tours. We're taking an old problem, which is manufacturing, and we're taking a new idea, which is big data. And so by combining all those together, we've seen a lot of success in what they've been able to do for the company. The second quote is actually by our founder, Bill Boeing, and it is, we are embarked as pioneers upon a new science and industry in which our problems are so new and unusual that it behooves no one to dismiss any novel idea with the statement that it can't be done. And we like this a lot as well. We feel it applies exactly to our team. Sometimes it can be hard in a big multinational corporation to think that you can actually have an impact on what goes on. But that's exactly where we've kind of found ourselves, is we have a relatively small team, 10 to 15 people inside our larger scientific imaging team. And the work we've been doing with the virtual tours and our tools that we've created have found their way into production on a daily basis, and they are making a difference. So it's a really good feeling to have that we're able to do that and make a change. So.
So much like, hello. There we go. So much like Brian said, we've got a bit of a learning curve as we started up, and we haven't let it stop us, and we've been able to take some inspiration from people like Aaron Spence, Catlin Seaview Survey, and Sergei Semenov and Airpano, and the amazing quality that they've put together, and then of course Alexander Jenny and Collar. And it's been a great journey, and where we started off actually was shooting 360 images for maintenance training. They're essentially the Boeing team that trains the airline customers to maintain their aircraft, and so they use the 360 images to give them context to their training manuals, and it can take oftentimes a week or 2 weeks to get the training teams in and trained so they can maintain the aircraft. And 360 images were helpful in showing where the different assemblies and parts and processes were on the aircraft. But we saw a lot of interest and value in that, but we wanted to be able to connect more with the process, really integrate the capability of 360 images with a more integrated system. So we started looking around and trying to understand some of the more internal Boeing processes and data-driven aspects of it. So this is just kind of a fun 360 little planet on top of the 767 line in Everett, Washington, a few of us up on top of the airplane. But the idea is you're looking at, rather than just a single photo of us, you got context of where you are, what you're doing, what you're looking at. And I know you're all familiar with that, but what its meanings for us is connecting the data, the actions, and driving an impact. All right, so it's fun, it's cool, but what do you do with it? So we found an interesting use case on several of the more legacy programs on the Boeing assembly plant in Everett, where you've got the world's biggest building by volume. You've got several processes where you need to go back, the mechanics and the shop QA need to go back and find a detailed bit of information, a job number that relates to a process on the airplane. Oftentimes, what the teams did is to help the teams find that information is document all of the jobs specific to their phase of the build process in a 3-ring binder. And it sounds a little silly, but the data sets were in so many different systems and so many different areas. A lot of times it was difficult for the new team members to find that information. So they put it all together and put it in a 3-ring binder. Great. Oftentimes, though, the 3-ring binder was not available, or it was lost, or it wasn't kept up to date, and it became very, very cumbersome. It wasn't searchable, it wasn't super well organized, and so it would take often hours to find that information. So we talked with the teams, and we found out that it would make a heck of a lot more sense if we could integrate that data set into a virtual tour. So as you're walking through the plane, you can say, oh, here's that part, here's the assembly information I need, it's visual, I can search for it, it's right there, and everybody can access it and keep it up to date. So that was one of our first implementations that we're able to connect the different data sets with the virtual tour. In another one, later down in the build process, we started finding that actually our own team was capturing hundreds and hundreds of images of each first of model. So this is these are the aircraft that have a unique configuration. So say United Airlines buys 100 aircraft, and then 10 of them are this configuration, and they have a new color or a new seat design or a new layout of the interior. And so each of those new configurations we call a first of model. And so our team comes in and captures hundreds of images detailing the new designs, the new configurations, all the little nuances and new technologies that get integrated in each of those new deliveries and new configurations. And so what we used to do for the past 50 years is provide contact sheets, and we upgraded to the web, but we provided a very long list of thumbnails and detailed photos that you could pull up, and the engineers could reference when they build their new designs. And it was an interesting tool, and it's a great tool, but we started to find that while they're organized kind of front to back, left to right, it didn't provide a whole lot of context or a whole lot of visibility of how those designs fit in the overall flow of the plane. And so we started introducing 360 360 photography to that capability, and this allowed us to organize and provide the same service, but allow context to flow with those. It actually allowed us to get on the plane and off the plane faster. We ended up shooting slightly less photos. The 360 photography became a lot more efficient. We're able to get in and get out faster, which then enabled the teams to have more manufacturing time, which was kind of the whole point. So we're able to provide a much more enhanced, capable product for Boeing. The images have been very helpful before, but now they've got a lot more context and a lot more drive. So that is this guy. So I've got a quick little demo that shows some of the additional capabilities of that system as well. So some of the new things that we, see if I can get this to play. Ooh, fun. Some of the new capabilities we come up with in the last few years allowed us to do things like new lighting technologies that got rolled out with the 787, get to highlight some of the different lighting modes and sunset and sunrise and star fields and fun things like that. And you're able to zoom in and get lots of resolution. So we aren't able to use the point and shoot style single shot images just because the amount of fidelity and resolution that our business partners are looking for on these things. We're zooming into carpet fibers and seams and blending patterns, and it's a very critical service that provides a lot more capability than we're able to get out of most of the single shot systems, just because the distance to subject is so much greater than a small camera can support. All right. So for another use case, this kind of ties back to what I was talking about with the three-ring binders. What we've got here is an augmented reality virtual tour. So this is a bit of a switch from the traditional, what we've been talking about this whole week is virtual reality. We're not delivering these tours on an occluded device, so it's not a head-mounted display. It's a visual reference guide. So it's something you can pull up on a tablet, on a phone, on a computer, on your desktop. It fits more with the processes that are used at Boeing. We're not going to be using ever a head-mounted display on an airplane when you've got too many dangerous situations around you. You need to be very aware of your situation. So when we go in and shoot these, we have a specific three-point location where we set up the camera, reference to airplane coordinates, and then each of these highlighted parts that you're looking at are actually assemblies that get installed in this phase of the build when the airplane is in this position. And so I'll see if that'll run. There we go. So you've got an interactive statement of work that you can walk through the plane, and through each 360 image, you've got a quick reference guide to see where all that information is stored. When you roll over each of these highlights, you get the job number, the installation plan, the three-point coordinates of where it is, and the description of what that assembly is. We added in some tools so you can quickly capture, copy, print that information out. We also added in a search feature so you can actually type in the job number you're looking for. It'll jump you to that location in the tour and quickly reference what you're looking at. So it's a way to visually navigate and search complex data sets. So the system before with the three-ring binders oftentimes had drawings or quick detailed photos, but this kind of system allows us to provide much more context to that data. All right. So for my last use case, I wanted to show you one that we've put together in the last couple of years. We're pretty excited about this. We called it Web Tools. But essentially what it is, it's an interface for end users. So end users, for example, we have the 787 being built in Everett and in Charleston, South Carolina. So very different locations in the United States, long ways away. They oftentimes are communicating on the phone or IMs or emails and FaceTime and things like that, so you can quickly communicate things back and forth. But you're still trying to connect data sets to the actual physical aircraft. And so what we did is we created an interface that meets their processes, where you've got line numbers, you've got job numbers, you've got IPs, and you've got quality information that you can update into the tool. Then you can tag that location of the data set into the image, so you can see where that information is relative to the build of the aircraft. That allows the teams to collaborate effectively together, create best practices, update shop aids and new tools, and integrate those new systems into the aircraft and build process much more effectively than we could with a single detailed photo or drawings or other processes like that. I've got a quick photo to show you kind of how that works. So this is the cargo deck or B deck of a 787. You can move through the plane. You've got lots of resolution. You can zoom in Fun fact, the tennis balls on the ceiling are so you don't bonk your head. There's a lot of protrusions and safety things in there, and they found tennis balls were a nice way to make sure people didn't hurt themselves. But essentially, you can pull up the data sets, filter it by the jobs that are being worked, and then connect it to where it is in the tour by clicking on the look to function. The teams at Boeing are using this tool daily, every shift. There's 3 shifts a day, so hundreds and hundreds of users every day are using this specific application to make sure that they can reference the updated data information connected to the jobs that they're installing. All right, back to Brian.
All right. So we talked a little bit about what we do. Let's talk a little bit about how we do it. So up here you see a rough overview of our process. This process has been the result of years of iteration and experimentation. And we've finally got it down to a point where it's repeatable and it's consistent. And more importantly, it's scalable as demand for what we've been doing has grown inside the company. The second stage on this is requirements gathering, and that's probably the most important part of this whole process, and that's where we sit down with the business partner and we get literally every piece of detail we possibly can from them as to what they think they want, what we think they might need in addition to that, how it will be used, how it could potentially be used in the future in addition to that, the logistics of the shoot and all that stuff. And that really drives the whole rest of the process. And we've really gotten it down to a point where, over time we figured out every little point where we could potentially reduce manual labor, replace it with some automation, figure out which parts can work together in parallel to save time, because pretty much time is everything in what we're doing, and trying to turn it around and get it so they can use it. But we refuse to sacrifice quality in that goal, so while time is everything, quality is right before it. But yeah, so I don't have time to go into all these in detail, but I wanted to break out the image processing step a little bit. So it's kind of a snapshot of one of our standard processing sheets. Starting with the first column on the left, that's the most important column here. That is a list of all the scenes that we captured on the aircraft at the time of the shoot. And they're all named specifically to a very detailed naming convention that's been kind of thought out and iterated and just really honed in to the finest point. So that name will include anything from the program, the airline, if applicable, specific line number of the aircraft, the build phase that it's in, so what stage of manufacturing that we captured it in, and then most importantly, the 3-point location of the camera on the aircraft at the time that we shot it. That 3-point location drives a lot of the automation in our process. It drives a lot of, such as the automatic map generation, automatic navigation between the scenes. And so it's key in our whole process, but after delivery, it lives on as pretty much a key point of information for anybody using the tour. So it gives them that reference of where they are on the aircraft, and it's a standard 3-point location system that everybody uses. So when they're dealing with work instructions or anything like that, they also have 3-point locations. It's super easy for them to correlate where they are, and again, give them that context of what they're doing on the plane. And so quickly, yeah, the rest of that just kind of walks through the rest of the process. So it'll be like where it is at each step: processing, stitching, retouching, quality assurance, and all the way up to write-off for final delivery. Okay, so in terms of technology, we work in a very restrictive environment, obviously, and so proprietary solutions aren't really the best option for us. While we've used them in the past, they almost always result in unnecessary pain points that arise. And so over time, we've really settled on open source standardized platforms to build our tools on. And so as we see here, the backbone of the internet, HTML, CSS, and JavaScript, all open, all extremely versatile, all easy for a lot of us on the team to already use and program in and design in. They really give us that transparency and that security that we need in our environment, where we know exactly what's going on inside all of it, and we can change whatever we need to integrate with any other system inside the company. That's one of our big pluses, is that any other system in the company that has either open access to data or an API, which is even better, or anything like that, we can integrate into these tours if so desired. And Jeremiah mentioned a little earlier before, but we really like to think of ourselves as democratizing access to data in the company. There's a ton of data that we have, and if you can't get to it, what good is it? The tools are of no value if they can't be used. So, and we get asked a lot, like why? Because this seems a little low tech. It's just web. And we get asked a lot. Similar to Jeffrey's presentation at the end, he was asked a question on Monday of, well, why doesn't he use Unity instead of 360 Tour? Unity is great and it's got its purposes, but for us, web-based tools and solutions are driving the success and adoption of this inside the company. And related to that is the devices that we use it on. So again, as mentioned, we don't use head-mounted displays. Yehu, yesterday, I was really excited to see he put up a slide about industrial restrictions and challenges, because nobody really thinks about that and talks about that, but we're in a very unique industrial manufacturing environment. And some of this cool tech that seems like it could be really useful, we'll never be able to use it, quite frankly. The head-mounted displays are great, but again, they block out your environment. It makes things very unsafe. In some of our, like in the satellite factory, additional restrictions apply, such as ESD. Pretty much we can't have any wireless, anything, anywhere near the spacecraft. So that kind of kills a lot of things that need apps or, any sort of network access or anything like that. So really, phones, tablets, and computers, things that are already in everybody's pockets or on everybody's desk in the company. They work. Anything with a web browser can basically use our tools. And so we're really able to give them a consistency of experience no matter where they are in the company. It gives us that security and that safety like we talked about. And it's just any device, anywhere, anytime, our tools can be of use. So it's been key.
All right, so I know we're a little short on time. Oops. I know we're a little short on time, and I've got a couple other use cases I wanted to go over quickly. I didn't get to show all of these get them all released to go into videos with, but they're kind of fun to see. The top left one here is one that we've developed a few years ago, and it's gotten a lot of attention at Boeing. What you're looking at is the left-hand side is a full airplane 3D model. So every airplane that Boeing builds gets a full 3D model. So everything on the Boeing defense side, the Boeing commercial side, utilizes some form of a 3D model. What we've done is we've connected the virtual tour to the model. So as you move through the virtual tour, you can match that viewpoint in the 3D model. This has been an incredibly powerful tool to be able to compare the designed configuration to the delivered configuration. And while those are normally the same, sometimes after delivery, you'll have customers come in and change the configuration, put in modifications, new customizations, and being able to compare the current configuration to how the original design has been an incredible aid for new designs and new capabilities at Boeing. It also allows you to connect data sets that are unique to the 3D models, such as part numbers and data sets that are embedded into each unique airplane. So we do shoot many, many different virtual tours. We're delivering 2 new tours every week. We have a lot of different data sets that we're able to leverage through the 3D models. On the right-hand side, on the top, you've got a photogrammetry tool that we've created that utilizes big data, connecting large amounts of information to the locations where it's applicable on the aircraft. So you can filter and sort that data and display it instantly on the image via the web tools. This allows us to focus in on different parts of the plane that are relative to the data sets, rather than just looking at an Excel sheet and trying to understand what it's trying to tell you. It's a way to much more easily ingest that information and take action on it appropriately. We do, of course, use the tours for trade shows and air shows and things like that, but it's honestly roughly 1%, if that, of the projects that we support. There are other teams at Boeing that use VR. It's much more experiential. They use our images occasionally, but they're much more focused on modeling, 3D models and things like that. We also shoot high-res gigapixels. The airplanes are big, but we want to be able to provide a very accurate record of the build. This image allows us, is a full 747 wing, I believe. You can zoom into the image to see each individual fastener. The images are very carefully gone over in reference to you have hundreds of images, right? They all get stitched together. We go through each individual image and make sure that every fastener that was originally recorded is the one that ends up there. So you don't end up with 6 fasteners where there should be 5. So our images through our process that Brian went over are every 360, every gigapixel is correct at the time of the build and the record of what was delivered. So, in closing, thank you very much for letting us take a few minutes of your time. First, second, always keep it simple for the user. It's very, very easy to make things complicated, but it's very complicated to make things easy. And it's a lesson learned that we've learned over the years, and it's an important thing to keep in mind. Is we want to focus on the users. They're trying to make their jobs easier. We're not going to be able to deliver them a tool that's going to be successful. It's hard to use. So you really got to understand what the problem is that you're trying to solve, connect with the end users on a individual basis, really get that understanding before you build a tool and then give it to them and then expect them to use it. So we're excited to be able to provide context to data that supports internal Boeing processes and has delivered some amazing results for Boeing. And I think that's it.
Thank you very much, both. Okay, first question.
Hello, thanks very much for that fascinating insight into how you can actually make sort of photography a core part of the engineering process. I admire your perseverance to get to that stage, so that's excellent. I was just wondering if you add other content such as videos of workflows or installations, that type of thing. Is that the type of thing you add to the database as well?
Yeah. We can basically add any sorts of attachments we want, and really each project comes down to the specific requirements for that business partner. So we have the ability to add videos, PDFs, things like that. I think we're moving towards a point where the tours are just kind of one-stop portals for all the data for that program, and so we really like to have it at a point where every tour just by default has access to all of their digital information and data, no matter what format that it's in. So, yeah.
Yeah, work instructions have been really powerful because you can attach the work instructions relative to the locations in the images and the build phases. So one thing we didn't really get to show very much is that you can switch the 360 images from structures to systems to final delivery, and being able to integrate different data relative to that phase of the build has been amazing. Yeah.
Absolutely fascinating. Thanks very much for sharing your insights. One of the examples you showed, which is the AR one, I was looking at that and trying to understand more about the process of how you looked at the inside of a fuselage and you saw various components, all of which were color-coded, looked very detailed, and you're talking about how you can link from those items through into like your data sets. Is that something that you're doing by linking the 3-axis positioning of the camera and linking that to a CAD model, or does somebody have to manually trace out those elements? You know, because the later case study you just touched upon, you were showing how you could flick between a high-res kind of CAD model and the virtual tour. I thought, have you guys nailed the kind of camera positioning so that you're able to line up stuff?
Great question. We've looked at that a lot. We've tried to figure out some ways to automate the placement of those polygons. Short answer is no. They are manually placed. What we started doing is originally our team worked with the business partners directly, and they would come over and we would transcribe that information onto the outlines. we found out, though, is that it quickly became way too much work and to overload our system and process. So we built an actually online tool so the end users can go in and update and maintain that data set themselves. So they have manufacturing SMEs specific to that phase of the build, and they go on and say, this is the outline. It's very quick. It's a web browser. They can annotate it themselves. They can add in the data. The data is already pre-populated. They just select it and tag it. So it's not automated, but it's semi-auto.
Yeah, that's going back again to Jehu's presentation yesterday. It was one of the things where we took a lot of pride in how well we did those, the tracings and all the stuff. And when it got to the point of trying to decide like what to do about it because it was so much work, and we're like, well, this is work. Why would we give away work? But it became pretty obvious that, there was no reason to introduce us as a middle person into that process. Like, we were dealing with the engineers and then going back and then having them do all the check-in. It's like, well, why don't we just, our teammate built a tool and you put it online and we train them. It's like, here's how you outline things. It's a simple polygon tool, and then they can take care of all of that double checking and make sure it's all right. And to be honest, that has freed us up to do more work, just similar thing, right? It's like, yeah, you can give that away, but more will come. So it just built more demand for what we were doing. So it all worked out.
First, thank you very much for sharing this big thing. I think the biggest thing is to show how these virtual tools can be really used by a company to do something, and not only to show a product or a place. Then a quick question about the system you built. Did you ever thought to integrate these kind of things in a common site construction software that's called GIS?
Have we done that? Is your question?
Yes, if you have done, if you thought about integrating this for GIS is used by architects for
yeah, we haven't really had a request for that or a demand for that, so we haven't done that. What I do know of GIS, I don't think it would be a problem. I think we could do it if we had a need to do so. But yeah, that's, again, harkening back to using standard web technologies for everything that we do. It enables us to interact with anything like that is accessible. So that would be a very cool project. We just haven't had a need for it.
Yeah, they have a lot of very unique systems and processes inside of Boeing, and each program kind of has their own in some situations, and it's been much more effective to be able to use the open source standard technology to be able to connect with those. So I'm sure we could, but it's all about integrating with the right process.
Okay, thank you very much.